This is the beginning of another three-part series on trig identities. We're going to verify about 3 trig identities in each of these next 3 videos. These are a little bit more advanced, so you'll notice that they take a little bit longer, and they also involve more algebra and more sort of different formulas or other trig identities that kind of go and are embedded inside of them. So remember, when we talk about these things, right, we have some guidelines. We always want to work with one side of the equation at a time. Try the more complicated side first. When we verify these identities, we can't really treat them, if you remember, we can't treat them like an equation, because that's really what we're trying to verify, that it is true. So in other words, you can't just say, okay, let's subtract cosecant x from both sides. It doesn't work like that, because we don't know that the equation is true yet. Our job is to verify that it's true. So we have, sort of a different set of rules here in terms of moving across that equal sign. We can't do it at all. We're going to use a ton of algebra. We're going to factor. We're going to add fractions and things like that. We're going to use difference of squares, difference of cubes. Number 3, we're going to look at a lot of our fundamental identities, turning things into their reciprocals, Pythagorean, odd, even. When all else seems to fail, we're going to convert things to sines and cosines, and of course we're going to always try something. Our main identities that we're going to use are right here. We've seen these before, so I'm going to keep reverting back to these. We're also going to use some double angle identities and some other stuff, so it's a little bit more complicated than my first 3 videos. If you haven't watched those first 3, please check those out before you watch these 3. As I said in the first round, I can definitely make a lot more of these trig identity videos. There are tons and tons of examples that I have that I use in my class and on my tests and practice worksheets and stuff. So over the next couple months or years, I might continue to add even more advanced identities on here. But let's get started. So we have sine x plus cosine x in a binomial times another binomial. Get that to equal this whole thing. Well, the left side seems to be more complicated, so let's FOIL this. Let's distribute this binomial into this binomial. So let's go first times first. Sine x, tangent x. Let's go outside. So sine x, cotangent x. Let's go inside. Cosine x, tangent x. Let's go last. Cosine x, cotangent x. And we're trying to get that whole left side to equal this crazy thing over here. Alright, let's turn the tangents and cotangents into sines and cosines. So we have sine of x. Remember, tangent is sine over cosine, so let's change that. Plus sine of x is equal to cotangent, which is the reciprocal of tangent. So this is cosine over sine plus cosine. Turn tangent into sines and cosines plus cosine times cotangent in terms of sines and cosines. We're trying to get that whole left side to be secant x plus cosecant x. A little algebra here. Let's multiply this sine times this sine and this sine times this cosine. Well, those will actually just cancel out. But let's multiply this sine times this sine, and we get sine squared x divided by cosine x. These signs, of course, cancel, leaving us with just cosine x. Here the cosines cancel, so we'll just have sine of x. Here the cosine gets multiplied by the cosine, and we get cosine squared x over sine x. Alright, so now we need to find some common denominators, looks like. So I'm going to group these in kind of an interesting way. I'm going to take these 2 as a pair, and I'm going to take these 2 as a pair. So my common denominator for this green pair is cosine x. So this one's already fine. That one already has my denominator that I'm looking for. This term needs a denominator of cosine. So that means my denominator is cosine x. I need to multiply the top by cosine x as well. My denominator in the orange is going to be sine of x. All right, a little algebra, and we're trying to get that whole left side to be this. I keep bringing that down just so I don't have to scroll back up. Again, let's add the green together, and we get sine squared x plus cosine squared x over cosine x. Add the oranges together, add the numerators, keep the denominators. Pythagorean identity right here tells us that both of our numerators are 1. So it's 1 over cosine x plus 1 over sine x. And what do you know? We have reciprocal. 1 over cosine x is secant x. 1 over sine x is cosecant x. And we are done. Let's move on. Okay, here we have a numerator that has these exponents of 3. I would definitely say the left-hand side is more complicated looking, so let's take a look at the numerator and notice that it's the sum of 2 cubes, the sum of cubes formula. So over here I'll write that down, the sum of cubes formula. And the sum of cubes formula basically says, all right, if you have like a to the third plus b to the third, the rule is you take your first thing plus your second thing with no exponents, and you multiply that by the first thing squared minus the product of both a and b plus the second thing squared. All right, and that's just some algebra there. If you need to go back and look at your sum of cubes formula, go ahead. I'm going to assume that we have a general idea of what that is. Because if you're looking at this video, you're probably in calc, pre-calc, or some sort of advanced algebra 2 or something. So I'm assuming you know the sum of cubes formula. From here, all right, we can see there's a really nice cancellation. We have this whole sine x plus cosine x over this whole thing, so we'll cancel those out. So that leaves me with, let's see, sine squared x minus sine x cosine x plus cosine squared x. That whole thing, believe it or not, we need to get to equal this simple little binomial here. And you need to have a sort of the ability to kind of see easy stuff when the equation looks kind of more complicated. If you look at those two things, they're added together. When you add those together, it's the Pythagorean identity. That's just 1. And then if you just bring this little binomial down, you have exactly what you need. So you're finished. Last one for this video. And I'll mention again here before I start this problem that, if I do this in 6 or 7 steps, it doesn't mean it's the only way to do it. You might be able to do it a little bit easier. In other words, you might be able to turn my 6-step verification into 5 steps, maybe even 4 steps. Maybe even you do it completely differently. That's okay. Doesn't matter. As long as you follow correct mathematics and you get down to the correct answer, it's fine. All right, so here I have a sort of a fraction equal to a fraction, and I'm going to change this right-hand side. If you wanted to change this left-hand side, you certainly can. I think when I first did this problem, I tried to, and it kind of led me in the wrong direction. So, a little hint here, let's start with the right-hand side. So at this point, I'd suggest that you pause it and give it a shot yourself. See if you can get down and make this whole right-hand side look exactly like this side. So go ahead and try that now. When you're done, press play and see if you got it right. All right, so here we go. I'm going to change my numerator into 1 over sine of x. And my denominator is going to stay the same. And I'm trying to get that whole right side to be this thing. And at this point I might just copy and paste this if I can select it. Maybe I can't. There we go. I need to bring that down a bunch of times. Save me some time. Like I said, I think this is about a 6-step proof. Can't really remember, but let's see. From here, I'm going to use a trick that I don't think I've used in my first 3 videos. And that's when you see a denominator that is, there are no squareds in it. All right, a lot of my students tend to think that this is cosine squared, so they can change this to, sine squared or something like that, but it's not true. If this doesn't have a 2 on it, you can't change the whole numerator to sine squared. So one of the methods that we're going to use is to multiply the top and the bottom by the conjugate of the bottom. And when we say conjugate, I'm talking about just change the sign in the middle. All right, and I can mathematically do this. I can multiply by this fraction because it's something over itself. So that's essentially just 1. I'm not changing the value of this fraction by multiplying it by 1. It's fine. So if I go ahead and multiply the bottom, let's do the bottom first. What I get is, if I FOIL first times first, outside, inside, and last. That's my denominator. All right, my numerator I'll just keep like this for just 1 second. All right, and the whole point of this, you're going to see in a minute here, was to turn my denominator into something that I can use Pythagorean identities on. So let me rewrite my numerator again. And I need to clean up my denominator. So if I clean up my denominator, let me move this down a little. I see that my cosine and my negative cosine cancel, so I'm left with 1 minus cosine squared x. And that is equal to sine squared x. So I'll do that now. That's a little Pythagorean identity. Okay. So now we have to work with that numerator. So let's go ahead and sort of just multiply these 2 things together. And when I do that, I get my numerator of 1 plus cosine x and my denominator of sine of x. And I'm just basically taking this and multiplying it by the numerator here. Just sort of combining those by multiplication. And I'll continue to bring this down. So let's continue. We have a little bit more work to do. I'm pretty darn close. I can see that I have a 1 plus cosine x, 1 plus cosine x. I just need to sort of manage these and get them to be sine to the 3rd power x. And that's just a little bit of algebra. Right? I see 1 plus cosine x over sine of x divided by sine squared x. So if I write that horizontally, I can see that dividing by something is the same as multiplying by its reciprocal. So I'm going to multiply by 1 over sine squared x. And now if I multiply right across the top, my numerator doesn't change. And my denominator, of course, is sine to the 3rd power. And I'm finished. Now you're probably saying, wait a minute, this is cosine plus 1, this is 1 plus cosine. Well, of course, a little commutative property. I'm not going to do that in this video. You can do that on your own. But that's generally the same thing. So there we go. That's the first 3. First part of our 3-part video series on slightly more advanced trig identity verifications. Thanks for watching.